So we know that on the unit circle, you okay? Okay. You know that on the unit circle, x is sine, or sorry, x is cos and y is sine, Calgary Stampede. We know that. Unit circle, it goes cos theta, sine theta. So if we wanted cos of 30, we would go to 30 and we'd take the x value and write it out, correct? And if we wanted sine of 30, we'd go to 30, we'd take the y value, write it out, correct? That'd be it. However, there's also tan. We agree? So let's just look at the 30 for now. So on my unit circle, on the edge, right here, at 30. I'll visualize it. Yeah, that wasn't even too bad. This coordinate is going to be root 3 over 2.5. We agree? Yes? Okay. We know that cos of 30, from what we did 2 days ago, is root 3 over 2. It's just the x value. We know sine of 30 is the y value, Calgary Stampede. So cos is x, sine is y. Do you agree? What is tan? Well, everything we do to find any other trig ratios on the unit circle, we're going to be using cos and sine, are we not? Because that's the only thing they give us, right? They give us cos and they give us sine. So every other trig ratio we look for, we're going to need cos and sine to find, okay? So we go to our formula sheet, which I told you should be your best friend and you should keep near you at all times. Tan theta equals sine theta over cos theta. That's what it says. So tan theta equals sine theta over cos theta. Which is the same as y over r. Or y over x. Y over x. Okay? So we know sine is y. We know cos is x. We know tan is y over x. So if we know sine and we know cos, we can find tan of 30, can we not? Tan of 30 is equal to sine divided by cos. When we divide fractions, we never write them over top of each other. That's just super confusing. Like a fraction divided by a fraction, that's super confusing. When we divide fractions, we invert and multiply what we're dividing by, correct? So how are you going to flip a bottom and then multiply it? That's just weird. So whenever we divide fractions, you always write them side by side with a division symbol in between. So we're going to do sine of 30 divided by cos of 30 degrees. Sine of 30 is a half. So it's not sine of a half. Sine of 30 is a half. I completely replace it with a half. We agree? Divided by cos of 30, which is root 3 over 2. I don't know why I'm in brackets, but I do. So cos of 30 is root 3 over 2. What do I do when I divide fractions? Yeah, kiss and flip, invert and multiply, flip, multiply, flip only the right hand side and multiply. Whatever way you remember it, just do that. So we're going to get 1/2 times 2 over root 3. And then when you multiply fractions, you just multiply across the top, across the bottom. So we're going to get 2 over root 3. 2 over 2 root 3, sorry. That's hard to see. You have a 2 on the top and a 2 on the bottom. Monomials. There's no plus or minus signs on the top. There's no plus or minus signs on the bottom. So the 2's can cancel. So I'm left with 1 over root 3. And then we can never leave it as a radical in the denominator. So we always have to rationalize our denominator, which means we need to get rid of the radical, which means we need to multiply by the radical. Because when you multiply two radicals that are exactly the same together, the radical sign drops off and you're left with just the number, right? Like I said, root 3 times root 3 is root 9, which is just 3. So we are going to rationalize our denominator. So we're going to get 1 times root 3, which is just root 3, all over root 3 times root 3, which is 3. So sine, we can pull right off the unit circle, it's the y. Cos, we can pull right off the unit circle, it's the x. Tan, we can pull right off the unit circle, it's y divided by x, right? Or sine divided by cos. On our formula sheet, it tells us that. New to us. Cosecant, secant, cotan. Cosecant, secant, cotan. Here they are. They're even written up here for us. We don't need to memorize them. It's great. Cosecant, secant, cotan. So cosecant is spelled CSC. Cosecant is best friends with sine. Secant is best friends with cos. I always remember that C's and S's don't go together. So cosecant is not with cos, and secant is not with sine. Cosecant is with sine, secant is with cos. If you're like, man, I'm never going to remember that, it's on your formula sheet. You don't need to remember it. Like, it's literally there. You just can look. It's fantastic. And then cotan is 1 over tan, but also cotan tells us up here, it's just cos divided by sine. So we would just do whatever we had before. Instead of doing y divided by x to get tan, we do x divided by y and we get cotan. So cotan on our formula sheet clearly states it's cos divided by sine. So cosecant is 1 divided by sine, which we can pull off the unit circle. Secant is 1 divided by cos, which we can pull off the unit circle. Cotan is cos divided by sine, which we can pull off the unit circle. So we can get every trig ratio by just using the unit circle, can we not? So let's find the other three. So cosecant of 30 degrees equals 1 over sine of 30 degrees. We agree? So that's 1 over a half. Would I ever write it like that? As long as something is a fraction, don't write them on top of them like that. It's just confusing. So I'm going to write it as 1 divided by a half, because sine of 30 is a half. We replace sine of 30 with a half. That is its answer. Okay? And then we get 1 times 2 over 1. What's 1 over? What's every number over 1? Every number is actually a fraction. Like 7 is just 7 over 1. We just don't write the 1. So now we're going to get 2 over 1, or just 2. So cosecant of 30 is 2. So when you take a number 1 and you divide it by another number, all you're going to get is the flip of it. Are you not? So cosecant of 30 is just the flip of sine. Secant of 30 is going to be the flip of cos, etc. But we can always fill it into the formulas we're given. So let's do secant 30. Secant of 30 degrees equals 1 divided by cos of 30. So we're going to get 1 divided by root 3 over 2. And when we divide, what do? Invert and multiply. You can guess. 1 times 2 over root 3. So I'm going to get 2 over root 3, which is a lovely answer. But what do I always make you do? Rationalize. Get rid of the radical. So what am I going to multiply them by? Root 3. We learned this in grade 11 last year. 2 root 3 over 3 is my answer. So if I ask for secant of 30, it would equal 2 root 3 over 3. The last one I have to do is cotan. Cotan theta equals 1 over tan theta. But instead of writing that, if we're using the unit circle, what would be better to do? Use the one with coses and sines, correct? So cotan over there says it's cos theta over sine theta. We're going to find cotan of 30. So it's going to be cos of 30 divided by sine of 30. Are we going to stack them on top of each other because they're fractions? Nope, not helpful at all. So we're going to write them sideways. So cos of 30 is root 3 over 2 divided by sine of 30, which is a half. Then I'm going to flip and multiply. So I'm going to get root 3 over 2 times 2 over 1. And then multiply across the top, across the bottom, so I get 2 root 3 over 2. If either the top or the bottom has plus or minus signs between terms, you can't do any canceling unless every term has the number. Do either of these have plus or minus signs in them, the top or the bottom? Nope. So if they both have a 2 in front, that 2 can cancel, and I'm left with root 3. So cotan of 30 degrees equals root 3. So I used the unit circle and the formulas off my formula sheet to answer all 6 trig ratios. So we have sine, we have cos, we have tan from before, and now we have cosecant, which is 1 over sine, secant, which is 1 over cos, cotan, which is 1 over tan, or cos over sine. All on your formula sheet. Don't need to memorize them. They're there. Okay? But what we do need to remember is we can go to our formula sheet and find them. Also, last year we learned about cast rule. You start in the bottom left and you go around and do cast. Or you can start in the top one and say all students take calculus except for you, because you're not doing calculus right now. So that doesn't really make sense. But if you want to do that, you can. Maybe all students take calculus in the future. I don't know. I just use cast, but whatever you want. So, do we know what the C means? Do you remember what cast tells us? It's where they're positive. So if I'm finding cos of any angle in this quadrant, in quadrant 4, my answer is going to be positive. Why does that make sense? Because cos is x, right? And all x's are positive here, are they not? Its bestie, secant, is also going to be positive here. Why is secant also going to be positive? Because it's just 1 over cos. So I take my cos and I flip it. So if my cos was positive, my secant has to be positive. Okay? Sine is positive in this quadrant, and so is its bestie, cosecant. The reason why sine is positive here, sine is y values. Are all the y values positive here? Yes? So is the cosecant, the flip of that, going to be positive there. Everything is positive here. Why? You're in quadrant 1. X is positive and y is positive. If you divide x's and y's, it's still going to be positive. So every trig ratio is going to be positive there. And tan is positive here, and so is cotan. Because tan and cotan, you divide sine and cos, which are x's and y's, you divide those. And if you're dividing x's and y's that are both negative, what's going to happen when you divide two negatives? You get a positive. So that's why any angle in this quadrant, so if I asked you for tan of 210, I know it's going to be positive. If I asked you for tan of 260, it's going to be positive. If I asked you for tan of 215, it's going to be positive. If I asked you for tan of 240, it's going to be positive. Because any tan that falls in angle in this quadrant is going to be positive. If I ask you for tan of 120, it's going to be in quadrant 2. Is tan positive here? No. And tan is sine divided by cos, so it's going to be a negative divided by a positive divided by a negative. It's going to give me a negative number. That's why cast works. Okay? All right. So, we also need to memorize our trig ratios. Go away. So we have sine. It's y over r. So if we're not using an actual angle off of our unit circle, we have to use our trig ratios. So remember SOHCAHTOA, right? When we did SOHCAHTOA, we always looked at just a plain old triangle, but we could look at either angle, and if it could be opposite, so this would be opposite at one point in time, and this would be opposite at another point in time, depending on which angle they gave us to look at. With the unit circle, we're always looking at angles centralized around 0, 0, right? We're always looking at ones from 0, 0 to the x-axis. So this is always opposite, and this is always adjacent. This is y, and this is x. Okay? Does that make sense? So adjacent is x, and opposite is y. So when you had SOHCAHTOA back in the day, we're going to have x and y, and this little bad boy, this is a circle that goes around, correct? So my hypotenuse is actually the radius. So wherever I had opposites, I'm now going to have y's. Wherever I had adjacents, I'm now going to have x's. And wherever I had hypotenuses, they're going to have r's. So I'm going to get y over r, x over r, y over x. Okay? Their reciprocal trig identities, which is cosecant, secant, cotan, are just those answers flipped. So if I can get my SOHCAHTOA really easy, I can get the other ones really easy. So I can go cosecant of theta equals this flipped, r over y. Secant theta equals r over x. Cotangent of theta equals x over y. So if I have the three normal identities down, knowing that opposite is y, adjacent is x, and radius is hypotenuse, then the other ones are really easy. You just write them flipped. Okay? So I want you to go to the very bottom of the sheet, if you have the sheet. If not, go to another spot on your paper. Don't look at what you have and give me the trig ratios. I want you to tell me sine theta equals what over what. And they need to be x's, y's, or r's. Cos theta equals what over what. Tan theta equals what over what. Don't look back. Use SOHCAHTOA. Cosecant is best used with sine. So once you have sine, just flip it and rewrite it. Secant is best used with cos. Once you have that, flip it and rewrite it. Sine is what? So, which is O over H. What's O the same as? Y, because it's opposite it and it's Y. And what's H? That's the easy one. R. So what's cosecant? R over Y. Right? Cos is ka. A over H. What's A the same as? X. And H is always R. So it's X over R. And then secant is R over X. Tan is TOA. O is Y over X. So cotan is X over Y. So you can use SOHCAHTOA to get all of them, right? You just need to remember that O is Y and X is adjacent. Okay? All right. Knowing that, let's go to this. So example 1, given the following points on the terminal arm of some rotational angle, find the exact value for all 6 trig ratios. So that's sine, cos, tan, cotangent, secant, cosecant. Exact values means not decimal. Okay? And we'll deal with the rotational angle later. We're just going to literally find the 6 trig ratios for now. So very first thing we do, we have a point. It's at -2, 6. The very first thing I'm going to always do, and everyone forgets to do, is I'm going to plot it. In order to do trig ratios, I need x, which is -2. I need y, which is -6. And I need r, which is I have no clue. Correct? So I'm going to plot it. -2, 1, 2, 3, 4, 5, 6. I'm going to plot that dot. It always connects with 0, 0. I always go back to the origin. And then I always make bow ties. So just like the reference angles are with the x-axis, this is drawn to the x-axis. So there's my triangle. It's always drawn towards the x-axis, never the y. You never make hourglasses. Like, you're not going to draw it like this. Make hourglasses. You're always going to make bow ties. So it always gets drawn towards the x-axis. Okay? So let's write what we know. We know this is -2. We know this is -6. How far art thou we going to find that radius? Pythagorean theorem, grade 10. It's a 9-degree triangle, is it not? I know 2 sides. Find the third one, Pythagorean theorem. So, the catch, for 1 second. Y can be negative, can it not? It could also be positive, could it not? X can be negative or positive, could it not? R is the radius. Radius is a length. The radius will always be positive. So even though you are going to take plus or minus your answer, you're always going to only take the positive if it's radius, because radius is length. So radius is always positive. So we're going to go r squared equals x squared plus y squared. That's always what we're going to use. I don't know what r squared is. And it's going to go negative 2 squared plus negative 6 squared. R squared equals 4 plus 36. R squared equals 40. Square root both sides. Oopsies, where did that go? When I take the square root of both sides, I have to take plus or minus. So r equals actually positive root 40 because it can't equal negative. We can't write root 40. If you put root 40, the answer is not going to be there. I think I got red on my sweater. It's always going to be the reduced version. If you can reduce that radical, you need to reduce that radical. So grade 10 and grade 11 math is extremely important in grade 12 because every time we do anything in grade 12, it's like grade 12 new stuff and then boom, grade 10 and 11 math. Grade 12 new stuff and then boom, grade 10 and 11 math. And where do you guys screw up? Never in the grade 12 stuff. You guys screw up in the 10 and 11 math. Like when you're reducing a quadratic equation, there was some really scary, like the quadratic formula, some scary math was happening in that quadratic formula. Some scary, scary math. And some reducing, scary. But the actual like polynomial part, perfect, right? So we just need to make sure that we have our A game on not just the new stuff, but also what we learned in the past that we just maybe have forgotten. Root 40. The only way we can reduce a radical is if we can pull out a perfect square, correct? Is there any perfect squares that we can break 40 into? 4 and 10. Let's only take out the biggest one. So we can reduce 40 into 4 times 10. Can the 10 come out? No, it'd be a decimal, so I can't take that out. Some people will say 8 and 5. Lovely numbers, really like them. They make 40. Neither of them can come out of the radical because both of them would give me decimals if I square rooted them. Like if I square rooted 8, I'd get 2 point something. If I square rooted 5, I get 2 point something, so lower, right? Neither of those are perfect. So when you guys are reducing radicals, some of you guys are pulling numbers that multiply to give that number, which are fantastic. Neither of them are perfect squares, which is sad. So you can't do the math. Okay, so they have to be a perfect square with something that's not a perfect square. If you can't get that, you can't reduce it anymore. It's done. Like root 13, let's say. Can't do anything to it. Can't make any perfect squares with it. Okay, root 21, let's say 21. I can't take any perfect squares that multiply to give me 21. Okay, 40, 4 and 10. The 4 comes out and it is a 2. That's gone. And so I'm left with 2 root 10. So my radius is 2 root 10. And it has to be positive because it's a radius. And now I can do every single trig ratio because I need x, y's, and r's. So what's our trig ratios again? Sine of theta. Now, if you just write sin equals something, you're telling me what sin equals. You're not telling me what sine theta equals. You're telling me what sin equals. It's a fraction. It's weird. I don't know. And then it's like cos equals this, and some cot thing equals this fraction, and some weird thing equals some other fraction. You need to have a theta beside it, or you actually do not have a trig ratio at all. You have a word equaling a fraction of some sort, which is not what we want, correct? And you're like, of course, Mrs. Lepp. And then you guys all leave off the theta, and you write sin equals fraction. You can't do that. You'll get docked. It is not real. It's just a word, okay? Unless it has a theta on it, it's not sine, okay? So you have to go sine theta. You could go sine x. You could go sine A for all you want because they didn't give us that it's theta or anything. But we have to have something beside that to represent that there's an angle there that we don't know what it is. Okay? So sine of theta is y over r. Because it's opposite over hypotenuse. So sine of theta is actually negative 6 over 2 root 10. I can take a 2 out of both of these, so it's actually negative 3 over root 10. But what do I have to do? Jack? I know. That's the only time I pick on people. So, what do we do? You know this. What do you think? Rationalize the denominator. What do we have to do? No. No flippy flippy. We want to get rid of root 10. Thank you. Not 3 root 10, just root 10. So that's sine. Then we're going to do cos. It's adjacent over hypotenuse, so x over r. Cos theta equals negative 2 over 2 root 10. The 2's can cancel. Multiply by root 10. And you get negative root 10 over 10. Then we have tan. Tan is y over x, because it's opposite over adjacent. So it's going to be negative 6 over negative 2, which is 3. Wait, it's positive. Why is it positive? That's positive in this quadrant. Tan and cotan, right? Those are my two, because of cast. The other two should be negative. Did I get two negatives when I did cos and sine? Yes, this is good. Cosecant is best used with sine. So instead of it being y over r, it's going to be r over y, which is nicer because r has the radical. So r is 2 root 10 over negative 6. I can just take a 2 out of both. And I get root 10 over negative 3. I don't have to rationalize anything. You can move the negative to the top. You can move the negative to the front. So you could say negative root 10 over 3. You could say negative root 10 over 3. You could say root 10 over negative 3. As long as there's only one negative in that thing, you're fine. If the negative sign can move, it could be in front, it could be in front of here. But I can only have one negative. And then secant is best used with cos. And cos is x over r. So secant is r over x. So it's going to be 2 root 10 over negative 2. So I get 1 over root 10 over negative 1. Would they ever write the negative 1 there? No, they're just going to write negative root 10. Three, you. So